All right. Good afternoon, everybody. We are Watchtower. Not quite as fun as Arduino Go here, but we definitely serve a purpose regardless. So we'll tell you a little bit about our project. Our group members here, as you can see, we have Max, Jordan, myself. My name is Stenik, and then over there we have Scott and Hugo. So we worked pretty hard on this product, like Jeremy was saying, to the very end. So yeah, basically it stemmed from a problem. Our problem was there's less than ideal manpower in a work environment, particularly in data centers and server rooms. And workers that we notice relied more on more and more screens, more tasks than ever than before. And they cannot maintain their attention on more than multiple things at one time. And this is a little bit of an exaggeration here, but you can definitely see that this can be some real world things as far as monitoring many security cameras, different screens. We have developers, people that are monitoring server rooms, things like that. And this is a quote from Leon Watson from The Telegraph. According to scientists, the age of smartphones has left humans with such a short attention span that even a goldfish can hold a thought for longer, actually. He also states that the results showed an average human attention span has fallen from 12 seconds in 2000 to around, or when the mobile revolution began, to about 8 seconds. And it's actually less than a goldfish. So our solution, naturally, would be just install goldfish, right? So that is not our project. Our real solution actually is going to be design a mobile-friendly piece of hardware that will let workers have peace of mind while they're doing their jobs. And also design software that will notify us when security issues arise in spaces such as server rooms and data centers. So what do we need for this? We need an Arduino Uno. As explained by the previous group, Arduino is a microcontroller that can do different processes and attach different hardware. We need a web server. And we also need an applicable and mobile platform that can show real-time data and push notifications as well. So as our Arduino goes here, we use the Arduino Uno board along with XB, just like our previous group here actually. So radio communication was of vital importance to us. And our diagram here actually shows our first part of our Arduino, which is our sensor boards. So our sensor boards had an array of sensors on there, temperature, we had photo, light, and we also had an accelerometer on there for motion as well. So these can be expanded. We had 2 of them in our project, but we could have more. Each of these boards transmit using an XB radio to our main Arduino board, which is shown right here. Our main Arduino receives the data and then transmits it to the MySQL server, which is actually run from Amazon Web Services. We pull that to a device using an application. So where are we going to see this information? We have the hardware, but where is it going to be pushed to? Well, our choice was Google Glass. As you can see, Google Glass is something that, as Jordan's showing you right there.
I'm going to pass this around in just a moment.
Google Glass is a wearable that was originally made as a beta program in 2013. It's a hands-free, lightweight, heads-up display that can be used to monitor, send, and receive data. And it is rare and very limited support with it, but it is a glimpse of what can be done in the near future. Google is no longer supporting this device at the moment, but it is opened the doors to many other technology.
I'm going to pass around glass just for a bit. If you have glasses, it might not play well with them yet, but if you can't see the eyepiece, you can pivot it here. I'm going to pass that around for you guys.
Okay, so how do we receive the data to the Arduino? The glass receives it in an application that's connected to the same server that the Arduino is connected to. It uses a database generated with Amazon Web Services, and the Arduino then stores the data. The glass then receives that data in the form of a push notification. This is an example here of our network diagram. So as you can see, we have our 2 sensor boards here, the 2 that we use, and also in the enclosure right there. That data from the XB is transmitted to our main board, and then from there it is being pushed to our web server and our database. At that point then, the notification is sent from AWS and sent to our Google Glass. As an example, we have a little topography view of a server room, data center type of thing, a very small room, but kind of getting the point here, the stars represent just important pieces of information that need to be protected. And of course, us in the corner there on our computer. If someone were to come and breach that area, there's no telling, what would be able to alert us. If we have our devices installed in different areas of a room, however, when the person goes to either steal or take information, our Google Glass can alert us. At that point, we can stop them. At this time, we're actually going to show a little bit of video of that little process that we've shown there.
Workplaces can be very distracting sometimes. We all know how hard it is to concentrate on the next task, all while trying to get through our day. In businesses that carry valuable equipment and information, one small distraction could lead to disaster. Thankfully, this is why we have designed Watchtower. Watchtower is built in a small enclosure and using the Arduino Uno microcontroller. Our enclosures can be used in multiple parts of a room, secured to a door, hidden remotely if need be. There is opportunity to add different kinds of sensors in the future. We have paired our design up with the Google Glass for a mobile heads-up display that will give us notifications when things in a room need attention. The information from the Arduino gets sent to a database wirelessly using Amazon Web Services, and there is access to a physical table of information. The data then gets pushed to Google Glass as a notification.
Okay, Glass. Read aloud. Okay, Glass. Delete this.
With our product by your side, you will absolutely be ready the next time something unforeseen happens in your workplace.
So, in the future, other platforms and wearables can be used with this. This does not have to be limited to Google Glass, of course. Many companies have been developing a type of heads-up display device or something with augmented reality, Microsoft being one. Google has definitely been thinking about supporting something similar to Glass in the future. Samsung with their VR technology, and even Apple's been rumored to make something as well. Even Snapchat has released their new product, Spectacles. We can actually have a little camera on the side that takes videos and photos, but not quite a heads-up display yet. So that technology is being developed. As an example here, this is Microsoft's Hololens. Very similar to how the Glass is, except it's a lens that goes across your entire face and actually can give you a augmented reality view. This is a great example of something that could be implemented with this type of technology in the future. We did have some design difficulties as we were going through this, as I'm sure everyone did. First thing was limited support when we were researching communication between our Arduino and the Google Glass, just because of limited support documents on the internet and things like that. Google Glass is technically a finished beta, and at the moment is not supported, again, leading into the issues with communicating with Arduino. And designing and securing enclosures to mount our circuit boards remotely across a room. One of the first things we would improve from this point forward would be making our enclosures smaller and smaller to be put in more remote locations. It was kind of difficult to get around that with the time constraints that we had. So, as a recap, our goal here is to make a mobile-friendly product that can effectively monitor conditions of a room and be able to tell you at a moment's notice. And the use of Arduino with radio communication, Wi-Fi networking, a database, and a web server pushing data to an endpoint are vital to this project. It's actually the entire backbone that we chose to create here. So, thank you.